Welcome to this episode of Robert's Creative Chronicles. So today, I'll be teaching you about mesh analysis. So mesh analysis is a method of analyzing circuits that uses mesh currents as the circuit variables. So this method, it uses Kirchhoff's voltage law and Ohm's law to analyze circuits, but it always uses mesh currents as circuit variables. So the end of this analysis, you're going to find the currents, the mesh currents. In this one, there are two mesh currents, I1 and I2. So, but what's a mesh? A mesh is a closed path along a circuit element in which there is no other closed path within it. So, there are two meshes here, A, B, E, F and B, C, D, E. So, this is a mesh. This is also a mesh. This one, A, B, E, F, E, all this closed one. This closed. So, there are two meshes here. So, a mesh is like a closed path along a circuit element which does not contain any other closed path within it. A, E, D, F is a loop. It's not a mesh because it contains two closed paths within it. So that one is a loop. A loop is a closed path along a circuit element that can contain another closed path within it. So a mesh is a closed path along the circuit element which does not contain any other closed path within it, while a loop is a closed path along a circuit element which may or may not contain any closed path within it. So here are the steps involved in doing mesh analysis. So the first step is to identify the number of meshes in the given circuit. So now I've taught you how to identify a mesh. A mesh is a closed path which does not contain any internal closed path or any other closed path within it. So this one does not have any other closed path within it. So it's a mesh. This is a path, but it does not contain any other closed path within it. But A, C, D, F contains two closed paths within it. So it's not a mesh. So there are only two meshes here, which is A, B, E, F and B, C, D, E. So now the second step in doing mesh analysis is to apply KVL to all the meshes. KVL stands for Kirchhoff's voltage law. In some of my previous videos, I explained KVL and KCL, that is Kirchhoff's voltage law and Kirchhoff's current laws. So I explained these two laws. The links of the video are down in the description. You can check them out for better understanding of this video. So for mesh 1, by applying KVL. So in this mesh analysis, you actually apply KVL and Ohm's law. So Ohm's law is voltage equals current times resistance. That is V is equals to IR. So when you are applying KVL to the first mesh, you assume current directions. These current are assumed directions of current. We don't know whether it's the actual direction, but they are assumed. On solving, if you assume direction of current is the same as the actual direction of the current, the value that you get for your current will give you a positive value. But if the assumed direction of the current is not the same as the actual direction of the current, the value of current will be negative, to give you a negative value. So if you assume in direction, at the end you will know the one that is correct and the one that is not correct. So if you assume any direction, you will know the actual direction at the end of your calculations. So let's apply KVL. Now we are moving in clockwise direction. Now when you are moving from negative to positive, there is a rise in voltage. So a positive value will be given to that voltage. Or like when you are moving in anti-clockwise, if you move from positive to negative, the value of voltage will be negative because there's a decrease in voltage. So here there will be an increase in voltage, which is from negative to positive, which here, so the voltage now will be positive, positive Vs. Then in resistors and conductors and other conductors, current moves from higher potential to lower potential. So when current moves from higher potential to lower potential, the initial point the current is coming from is at a higher potential, and where the current is always going is always at a lower potential. So when you are moving like this in the same direction as the current that is flowing through this resistor, you'll be moving from positive to negative. So the value we are giving this, the voltage in this resistor, is negative because current moves from higher to lower potential. We are moving from higher to lower also in the same direction. So our assumed direction is in the same direction as the current flowing through this resistor. So it will be negative. Negative, and the value of voltage in this resistor R1 is the product of current times resistance. That is V is equal to IR from Ohm's law. So that is I1 R1, and it's negative. Then this one here there is one current coming down, and here there's another current going up. So when two currents are coming against each other, the equivalent current is the difference between the two. And we are working with I1 here, so I1 will be our initial current minus I2. So it will be I1 minus I2, the value of current flowing through this resistor, then times this resistor. And since we are moving from higher to lower potential, it will be negative. So it's negative I1 minus I2 times R2. So negative I1 minus I2 times R2. So we are done with this. Then the next mesh, applying KVL to mesh 2. Here will also be, okay, we'll start with R3 here. So here will also be, the current flowing through this is negative I2 times R3 because we are moving from higher to lower potential. So it's negative. There was negative here, but since everything was negative, we just multiplied by negative to give everything positive. That's how we got all positive. But here there will be negative initially, then I2R4. Then I2R4, the current flowing through here will be negative I2R4. Negative I2R4. Then here, since there are two currents, this one will be coming like this through here, and this one will be coming like this through here. So to be I2 minus I1. It will be negative here, I2 minus I1 times the resistor R2. So since everything is negative, we multiply by negative to get everything positive. So that's how we got everything here. So then you solve the above equations for mesh currents. So you solve these two simultaneous equations. You solve them using any method you wish. You can solve them using elimination method, substitution method, or Cramer's rule, anyone that you want to do. And then you find the mesh currents. As I said before, if any current that gives you a positive value, it means that the assumed direction of current is the actual direction. But if anyone gives you negative, that means the assumed direction is not the actual direction of current flow in the circuit or in the mesh. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.